Hello geometry students, good evening and welcome to another video. We are in section 10-2 and we're going to talk about how to calculate the area of trapezoids, rhombuses, and kites. So what I'd like for you to be able to do is to be able to find the areas of trapezoids, rhombuses, and kites by applying the correct formula and by manipulating those formulas. So what we're first going to need to talk about is what those formulas are. So up here, I'm going to give you the formula for the area of each of these different types of polygons. The formula for the area of a trapezoid is 1/2 height, and then in parentheses, base 1 plus base 2. For a rhombus, the area is equal to 1/2 diagonal 1 times diagonal 2, and it's kind of convenient because for a kite, that's the same thing. So 1/2 diagonal 1, diagonal 2. Now, when these things are right beside each other, that means multiplication. So make sure that you are multiplying all those numbers together and not sticking in any addition symbols where they don't belong. So let's just jump in with some examples. In example 1, it says find the area of the trapezoid. So I'm going to start off with the formula for the area of a trapezoid. Area is equal to 1/2 height, base 1 plus base 2. Now, we know the height is going to be the vertical distance from the two bases, and it needs to be perpendicular, so we got that 90-degree angle. So I'm going to say the height is equal to 4 from this image. I'm going to say base 1 is the top one, so that's 6, and base 2 is the bottom one, 8. Now, the bases of a trapezoid are the parallel sides. So I said 8 and 6 are the bases because those were the two that were parallel. All right, so now it's time for us to plug into our formula. I'm going to have area is equal to 1/2 4 times 6 plus 8. Now, when I add 6 plus 8 together, I'm going to get 14. So now I'm at area is equal to 1/2 times 4 times 14. And now you can just put this straight into your calculator or do it in your head. 1/2 of 4 is 2, and 2 times 14 is 28. So area is equal to 28 units squared. Alrighty, there is our final answer for that one. Now, I'm going to skip example B for the video because we're going to do those in our notes during actual class time. So let's jump down to example, or part C, I should say. It says find the area of the kite. So the formula for the area of a kite is equal to 1/2 diagonal 1 times diagonal 2. Now, it doesn't matter which diagonal you say is which, just make sure that you keep track of it and you don't accidentally use the same one twice. I'm going to say diagonal 1 is the vertical one, so it's from here to here. The diagonal is not equal to 10, it's equal to 10 plus 10. So I'm going to say 20. So I'm going to say diagonal 1 is equal to 20. Now I need to figure out what diagonal 2 is. I don't know what diagonal 2 is yet because this 10 is only representing from here to here. I don't know how far it is from their intersection down to this vertex. So I'm going to have to calculate that. Hopefully something that you're noticing is that we have a right triangle right here that we can kind of focus in on where we can find a leg. Here's the thing. We cannot say 10 squared plus 26 squared equals c squared because the 26 is the hypotenuse. So when we use the Pythagorean theorem to solve for this missing side, just make sure that you know the 26 is the longest side. So I have 10 squared plus b squared is equal to 26 squared. Well, 10 squared is easy, that's 100, and you might need to use your calculator to figure out what 26 squared is. That is going to get us 576. Subtract 100 from both sides, getting us b squared is equal to 476, and when you square root both sides, you end up getting b is equal to 24. So I now know that this distance is 24 centimeters. From this point to that point. So the whole distance across that diagonal is 34. So from here to here is 24, plus another 10 is 34. Now I have my two values that I'm able to substitute in, so I can plug that into my formula. So I'm going to say area is equal to 1/2 20 times 34. And this is all multiplication. 1/2 times 20 times 34. Well, 1/2 of 20 is 10, and 10 times 34 is easy. That's 340. And so I'm just going to say centimeters squared right there. And there you have your next example, all complete. We're going to do this example with this trapezoid in class as well. So flip your page over to the back and we're going to do some of these examples. It says use the appropriate formula to solve for the indicated value. So you're not always going to be solving for area. Maybe you're given area and then you're going to try to solve for something different in the formula. So make sure you're reading your question carefully and you know what it's asking you so that you can answer it correctly. So just looking at this first one, it says find the area of the trapezoid. So we want to make sure we know what we're trying to calculate. Because it's a trapezoid, I'm going to automatically put my formula on here. So area for the formula of a trapezoid is 1/2 height, base 1 plus base 2. Let's write down everything we know. Height, we know, is going to be 4 because that is the vertical distance and it's perpendicular to the base. Height is always at a 90-degree angle to the base. Now we need base 1 and base 2. Now, the bases of a trapezoid are going to be parallel or going in the same direction. So clearly that's this side and this side. Base 1 is 8. But what's a little tricky is we don't know what this bottom base is. So we're going to need to use the image to be able to calculate that. So if I were to draw in another dotted line here, just so we can see this, we can clearly conclude, okay, this length is 8, which means from here to here is also 8. But how are we going to figure out what this length is on either side? That's a little strange. So what we have going on here are two special right triangles. They're both 45, 45, 90 triangles. So we've got a 45, 45, 90 triangle right here, and we got a 45, 45, 90 triangle right here. And we know one side of either of them. So we know the side of this one is 4, but we also know this side is 4 because the height of the trapezoid is not going to change. So because these are 45, 45, 90 triangles, you can do one of two things. You can set up your formula triangle. Whoops, not an X. We need a 1. 1 square root 2. And you can set up your proportion. So you can say 1 over 4 equals x over 1. You can do stuff like that. Or you can say, oh, the two legs are both 1. That means the two legs have to be the same length. They have to be the same. So if this side's 4, then right here is 4. And if that side's 4, then that side is 4 as well. I'm only able to do that, though, because this is a special right triangle. I'm not just pulling that out of the dark. These 45-degree angle measures and these 90-degree angle measures are making all the difference in the world. All right, so now we can easily figure out the bottom base. It's going to be 8 plus 4 plus 4, or 8 plus 8, which is 16. Now we have our three values that we need to plug into our formula, so let's do that. I'm going to say area is equal to 1/2 times 4 times 8 plus 16. Well, 8 plus 16 is 24, so let's do that. Area is equal to 1/2 times 4 times 24. Now we have it straight into multiplication, so 1/2 times 4 times 24. So 1/2 of 4 is 2, and 2 times 24 is 48. So I'm just going to do it like that. So I'm going to say area is equal to 48 units squared. And that's what we needed to calculate on that one. On this one, we are going to do example B in class, so let's skip down to example C. Example C says, what is the area of a kite with diagonal 1 equal to 12 and diagonal 2 equal to 1/3 of diagonal 1? All right, we're working with a kite, so that's important. I'm going to underline that twice, and I'm also going to circle what we're trying to calculate. We're trying to calculate area. So, to calculate area, I need to know my area formula. Area for a kite, if you don't remember it, remember we wrote it up here on the front of the page, but it's 1/2 diagonal 1 times diagonal 2. Whoops, I forgot my 1/2. There we go. Okay. We know what diagonal 1 is. Diagonal 1 is 12. Diagonal 2, on the other hand, is a little tricky. Diagonal 2 is 1/3 diagonal 1. So we can take this value for diagonal 1 and stick it in for that. So now diagonal 2 is 1/3 of 12. Well, 1/3 of 12 is equal to 4. So now I know my diagonal 1, which is 12, and I know my diagonal 2 is 4. So diagonal 1 is 12, and diagonal 2 is 4. I used the formula right here, or just the information that it told me, to figure that out. Okay, so I've got my values. Let's substitute them in. So I'm going to say area is equal to 1/2 times 12 times 4. All of this is multiplication. So I'm going to take 1/2 times 12, which is 6, and then 6 times 4, which is 24. So area is equal to 24, and we don't have a unit, so I'm just going to say units squared. And there we have it. We've calculated what we were trying to do. All right, I have one more example for you in these notes, and it is part D in example 2. So it says a rhombus has a perimeter of 32 inches and diagonal 1 is 6 inches. What is the area of the rhombus? Okay, we're trying to find the area of, and it's important, this is a rhombus. So all properties of rhombuses is going to apply. This one's a little more complicated, so I think it might be helpful for us to draw a quick image of what's going on. So sometimes it's simple enough that you might not need an image, but of course, if drawing helps you visualize it, then there is no shame in that, and absolutely draw your picture. So I'm just going to draw my best version of a rhombus here. And I know that a rhombus has all sides congruent, so I'm going to do that. I'm going to mark all the sides congruent. I'm going to go ahead and put in my diagonals with my 90-degree marker. This is a property of rhombuses. The diagonals intersect at a 90-degree angle. Also, the diagonals bisect each other. So this part's congruent to that part, and this right here is congruent to that right there. So this is everything I know about any triangle there ever was. But now I can start putting some information on here. So this says it has a perimeter of 32 inches. Okay, the perimeter is this side, plus this side, plus this side, plus this side. But all 4 sides on a rhombus are congruent. I'm going to write that over here just to remind you. All sides are congruent. So that means if they're all the same length, I can just take 32, which is the perimeter, and divide it by 4 to get us our value. Well, that is going to get us 8. So now on this image, I am going to say this side is 8, this side is 8, this side is 8, and that side is 8. After that, it says diagonal 1 is 6 inches. Doesn't matter which one you're labeling as diagonal 1, it really doesn't, but that's the whole diagonal. So if I wanted to mark the 2 halves, then I would say, okay, this half is 3 and this half is 3. So this is everything I now know about my rhombus. I'm also going to write the formula for the area just so we can see it. Area is equal to 1/2 diagonal 1, diagonal 2. We are almost there with all the information that we need. We need to figure out how big is diagonal 2 because we know diagonal 1 is 6. So how can we figure out how far it is from here to here? Well, what I hope that you're noticing, and we've been doing this a lot, right? We're going to use the Pythagorean theorem. We can focus in on that right triangle right there and find a value for that half of the diagonal. So let's do that. This is a right triangle, but the 8 is the hypotenuse. So I'm going to say, I'll do this in pencil since it's kind of side work. I'm going to say 8 squared is equal to 3 squared plus b squared. Well, that's 64 is equal to 9 plus b squared. Subtract 9 from both sides. And that is getting us 55. Square root both sides. And that should be getting us 7.4. So I put that into my calculator, and you can check if you don't know how to do that. You're just going, if you have this type of calculator, you're going to turn it on. You're going to hit the second key and then this key right here. Put in the value you are taking the square root of. And I'm getting about 7.4. I'm just rounding to the nearest tenth. Whoops. So that means only this half is 7.4. Also, this half is 7.4. So the total is 7.4 plus 7.4. Which is going to be 14.8. So now we know diagonal 1 is equal to 6, diagonal 2 is equal to 14.8. Let's substitute these into my formula. So area is equal to 1/2 times 6 times 14.8. That one I cannot do in my head as easily, so we have 14.8 times 3, which is 44.4. So we have 44.4. My unit is inches squared. And there we have it. So our strategy for this one was to draw a picture, label everything we know, use the Pythagorean theorem to figure out the second diagonal, and then finally use our area formula. That's everything for notes today. I hope you have a great night, and I'll see you soon in class.